Bipolar junction transistors are a kind of transistors. Both electrons and holes play an equally important role in their functioning, and hence they are called bipolar transistors. Two junctions exist in their structure, hence the term junction is included in their name. There exist three terminals in these devices, electronic devices. They are termed as emitter, base, and collector. Base exists in between emitter and collector. Out of these three parts, emitter is heavily doped, whereas base is lightly doped. Two types of transistors you can find in BJTs, PNP and NPN. Out of these two, NPN is widely used. Transistors are well known for providing amplification. They are widely used in the design of amplifiers and oscillators. Especially, it is so in case of BJTs. When the requirement is amplification, then the emitter junction has to be biased in forward direction and collector junction in reverse direction. When the transistor is biased in this manner, then it is said the transistor is in active region or active mode of operation. When it is in this mode, it starts amplifying the input signal. This amplification can be understood in two different ways. One uses current, another uses resistance. With the help of current, one can understand the amplification process by considering the transistor in active region and emitter releasing a current. This current then starts moving towards collector. While moving towards collector, it passes through base. As it requires to be passed through base, the resistance or conductance of the base affects or controls the current that reaches the collector. The base resistance or conductance can be varied in a very big way with the help of very small current into the base. So small changes in base current leads to large changes in base resistance or conductance, which ultimately leads to huge change in collector current. Net result is small changes in base current. It leads to very high or large or huge changes in collector current. Change in collector current to change in base current is naturally a huge number, and it is amplification factor or gain. This is one way of understanding the gain provided by bipolar junction transistor. There is another way. Through this way also one can understand gain provision by the transistor, that is with the help of resistance. When transistor is in active mode, base emitter junction, it is called simply emitter junction. Emitter junction is under forward bias, collector junction is under reverse bias. As emitter junction is under forward bias, its resistance is very small, and collector junction, as it is under reverse bias, its resistance is huge. When the transistor is functioning in active mode, the input current enters into emitter junction, a small resistor, and then it is somehow carried further and placed over collector junction resistor, which is of high value. So net result is current is being transferred from a low resistance to a high resistance. Current may be the same, but when we consider voltages, voltage across the small resistance, voltage across the large resistance, we can see there is a huge difference, a huge gap. Voltage across high resistance collector junction, it is very large. So at the input terminals, small resistance, small voltage. At the output terminals, large voltage. So output voltage to input voltage, naturally it is a great number. Of course, this is DC situation. Same argument can be used to understand small change in the voltage at the input terminals, giving rise to huge change in the voltage at the output terminals. It implies gain, voltage amplification. Transistors can be used in three configurations: common base configuration, common emitter configuration, and common collector configuration. In common base configuration, base is common for input and output. In common emitter configuration, emitter is common for input and output. In common collector configuration, collector becomes common to input and output. Out of these three configurations, CA configuration is considered to be the most versatile. CB is, of course, voltage amplifier. CC is current amplifier. These two have their own applications. Of course, they are small in number when compared to CE configuration. BJTs are semiconductor devices. They are fabricated out of semiconductor crystals. Silicon is widely used. Germanium is also used. Gallium arsenide. Several other such kind of semiconductors. Some are elements, some are composites. They are available. They are being used in the industry to fabricate transistors. In the fabrication, certain processes like epitaxy, oxidation, photolithography, ion implantation, etc. are used. Basically, there exists only 4 types of fabrication techniques. They are ground type, alloy type, diffusion type, and epitaxy type. By combining one or two with other types. One can have several varieties, several types of fabrication methods. To conclude, right now, BJTs are mainly confined to analog domain. Entire digital domain is occupied by FETs, MOSFETs. It doesn't mean that BJTs are not suitable for digital applications. There are applications, but MOSFETs offer more benefits when compared to BJTs when it comes to digital domain circuit applications are concerned. Electronic devices, BJT fabrication, series on semiconductor devices and circuits, lecture number 3.09. Bipolar junction transistors, BJTs, are semiconductor devices. They have two junctions, emitter junction and collector junction. Three parts, emitter, base, and collector. They are made with extrinsic semiconductors. The semiconductors widely used are silicon, germanium, gallium arsenide, and some more are also used. In the present session, we focus on the origins or different stages of development of BJTs and different types of fabrication methods that are followed in making a BJT. And at the end, a few important aspects pertaining to IC technology, integrated circuit technology, in which huge number of transistors are mounted on a single, very small chip. Let us start the session with a few points regarding origins of BJT manufacturing, early manufacturing techniques. Point contact transistor. First transistor ever constructed, it was a point contact transistor. It happened in 1947. It's a bipolar transistor. Bipolar means both carriers, electrons and holes, they participate in the functioning. They have limited commercial use due to high cost and noise. Then tetrode point contact transistor. This is point contact transistor but with two emitters. It became obsolete in middle 50s, 1950s. Then junction transistors. Grown junction transistor. This is first bipolar junction transistor and it was invented by William Shockley at Bell Labs on June 23, 48. Patent filed on June 26, 1948. Then alloy junction transistor. Emitter and collector alloy beads fused to paste, developed at General Electric and RCA in 1951. Micro alloy transistor, high speed type of alloy junction transistor. It was developed at Philco. Micro alloy diffuser transistor. It also belongs to high speed type of alloy junction transistor, but speedier than MAT, micro alloy transistor. It is a diffused based transistor. This is also developed at Philco. Post alloy diffused transistor, PADT. It is a high speed type of alloy junction transistor. This is also speedier than matte microalloy transistor. It is a diffused base transistor like MADT, previous one. It was developed at Philips. Then tetrode transistor, high speed variant of grown junction transistor or alloy junction transistor with two connections to base. This is the description of tetrode transistor. Then came surface barrier transistor. It is a high speed metal barrier junction transistor. It was developed at Philco in 1953. Then drift field transistor. It's a high speed bipolar junction transistor invented by Herbert Kromer at Central Bureau of Telecommunications Technology, German Postal Service in 1953. One can understand easily that efforts are being made in different parts of the world simultaneously to develop a semiconductor transistor. Then in 1957 came spacista. Before that, a diffusion transistor came in 1954. It is a modern type BJT, bipolar junction transistor. Prototypes got developed at Bell Labs in 1954. Under this, diffused base transistor, MESA transistor, planar transistor, these are all got developed. Diffused base transistor is the first implementation of diffusion transistor. MESA transistor was developed at Texas Instruments in 1957. Planar transistor is BJT that made mass-produced monolithic integrated circuits possible. It was developed by Gene Horney at Fairchild in 1959. Next, we move to epitaxial transistor, a BJT made using vapor phase deposition, which allows very precise control of doping levels and gradients. Now, we move to the present. The present doesn't mean really the present. The information being provided in the next 2 or 3 slides, this pertains to the technological state that existed some 25-30 years back. After giving this information, after 2 or 3 slides, we move to the current, exactly the present state. Now, transistors may belong to grown-up type, they may belong to alloy type, they may belong to diffusion type, they may belong to epitaxial type 2. These may be combined to form a large number of methods for constructing transistors. So grown type, alloy type, diffusion type, epitaxial type, these are basic types as far as BJTs are concerned. A few points regarding these types. Grown type. It is made by drawing a single crystal from a melt of silicon or germanium whose impurity concentration is changed during the crystal drawing operation by adding NRP type atoms as required. Grown type. Now we move to alloy type. Two indium dots are attached to opposite sides of N-type wafer, and it is raised to high temperatures in short time and cooled, forming a PNP transistor. Alloy type. Indium converts even N-type into P-type. Diffusion type. It consists of subjecting a semiconductor wafer to gaseous diffusion of both N and P-type impurities to form both emitter and collector junctions. Then epitaxial type. It consists of growing a very thin, high purity single crystal layer of silicon or germanium on a heavily doped substrate of same material. This augmented crystal forms the collector on which the base and emitter may be diffused. Here are illustrated the constructional features of BJTs. In A is shown grown type, in B is shown alloy type, in C is shown diffused planar types. A grown type is giving structural features of NPN transistor. N, this must be P, this must be N. Emitter, base, collector. A point to note here is the dimensions. Actual dimensions of the transistor are given here. One dimension is 1 mm, length is 3 mm, base is 25 micrometers. Notice base is very thin. It is also lightly doped, even though it is not shown or given clearly. Base is the lightest doped and thinnest one. Emitter is heavily doped. In B is shown alloy type transistor. P, this is N. Emitter, collector, this is base. Here also note base is 25 micro, 3 mm. Here also 3 mm, here also 3 mm. Last one C, diffused planar type. This is all P type. So emitter terminal is shown here, collector terminal is shown here, base is shown here, aluminum metallization, silicon dioxide, dimensions are 0.3 mm, 5 micrometers. So these diagrams give us an indication regarding the actual dimensions of transistors and their inner parts. IC technology, IC stands for Integrated Circuit Fabrication Methods. This technology is mainly meant for placing several components. Several means several thousands of components on a single chip. It all began with tens or hundreds of components on a single chip. Now it went up to thousands and thousands of components on a single chip. This is the current technological trend in electronics engineering. In this session, we consider a few important points, important aspects pertaining to IC technology. IC technology, when compared to conventional circuit composing methods, offers several advantages like low cost, small size, miniaturization, high reliability, and improved performance. These are all important aspects, especially low cost, small size, reliability, improved performance. These are all the things that are wanted in every case and in any case. The fabrication technology is making rapid strides leading to ultra miniaturization. The size of the device is going down and down. It is reaching to the size of electrons. With the decrease in the size of the devices day by day, number of devices that can be placed over an IC chip has increased tremendously over the last 6 decades. During 60s, it was only 1 to 10 devices per chip. Then it was called SSI, small scale integration. During the 70s, it is 10 to 100. It is called medium scale integration. In 80s, it was 100 to 10,000. It is called a large scale integration. At present, VLSI is running. In this stage, number of devices over a single chip is more than 10,000. After VLSI, it is said that it is ULSI. ultra large scale integration. After a brief introduction to IC technology, now we consider different processes that are used in fabricating devices on a chip. Large number of devices on a chip. Processes that are employed in integrated circuit or IC technology. One is epitaxy, another is oxidation, third one is photolithography, then diffusion, ion implantation. These are 5 processes used in integrated circuit technology. A few points regarding each one of these 5 processes. Let us begin with epitaxy. Several types of epitaxial techniques are available, like solid phase epitaxy, liquid phase epitaxy, and a gaseous phase epitaxy. This process basically utilizes pyrolytic decomposition of saline gas at 1100 degrees centigrade in the gas stream of a furnace where the substrates are kept. This process produces silicon particles which drops on the substrate and hydrogen gas which gets vented away. Now oxidation. Silicon dioxide is thermally stable and is primarily used for selective opening of windows during photolithography and etching process for subsequent doping and or metallization. In thermal oxidation of silicon, the source of oxygen can either be dry oxygen O2, the process being called dry oxidation, or water vapor or steam H2O, wet oxidation process. Here, complete description of these processes is not given, just a brief touch of these processes are presented here. Some points regarding photolithography. This is by far the most important process in the entire IC fabrication technology. With the advancements made in the photolithography technique, the device sizes have shrunk to hundreds of nanometers to below from tens of micrometers or above in the last 30 years. The term photolithography basically means a transfer of a pattern on the semiconductor surface using optical excitation. However, nowadays this term is being used even for non-optical excitations. This technique is used basically to open windows in silicon dioxide grown on top of silicon substrate to perform selective doping, metallization, contacts, etc. in order to produce devices and interconnects. This technique uses photoresist or resist, which is a liquid photosensitive organic polymer. The purpose of this small presentation on photolithography is to give a taste of it, not to describe it completely or totally. It is only an introductory treatment kind of thing. Now, a few points regarding diffusion. This is considered the most important process in the fabrication of ICs. It is fundamental process of doping the semiconductor, either p-type or n-type. Universally for silicon, boron is used as p-type dopant and either phosphorus arsenic used as n-type dopant. All these 3 elements have their gaseous sources in diborane, phosphine and arsine respectively. Lastly, ion implantation. This is an alternate and superior method of doping a semiconductor. Here, dopant atoms are ionized and accelerated through a chamber by the application of high electric field. These ions bombard the semiconductor surface and get implanted there, thus doping the semiconductor. Now we come to an end to the session. In this session, origins of development of transistor BJT. They are given and basic types of transistor fabrication are also given. And then a brief on IC technology, which made it possible to place some thousands and thousands of transistors on a single chip. It is briefly introduced along with various processes that are used in this technology. Hope this session is useful to you. We meet again in another session with a new topic soon.